Hello, hello students. Welcome to the next session. Okay. Today my topic is system of linear equations. Okay, which is the subtopic of Unit 4 Matrices of Paper 6 Linear Algebra. Okay, so system of linear equations. Here, system indicates that the equations are to be considered collectively rather than individually. Okay. In mathematics, a system of linear equations is a collection of one or more linear equations involving the same set of variables. Okay, okay. The graph of a system of two equations is a pair of lines in the plane. The intersecting lines at infinitely many points gives us a solution. Okay. And a linear system in three variables determines a collection of planes where the intersection point is the solution, gives us the solution. Okay. Now come to the topic, that is system of equations. In system of equations, there are two types of systems. One is homogeneous system of equations and the other is non-homogeneous system of equations. Okay. What is a homogeneous system of equations? As you're looking in the uh, PPT, that is the homogeneous system of equations will be look like this, where the first equation is a11x1 plus a12x2 plus so on a1 and xn is equal to 0. The second equation a21x1 plus a22x2 plus so on a2 and xn is equal to 0, and so on, where the last equation is am1x1 plus am2x2 plus so on amn xn. So these are the m equations, okay, in the number of in n variables. That is, the number of variables here are n and the number of equations are m. Okay. uh, the variables used here is x1 to xn. Okay. Here if you notice that the right hand side, all the equations are equal to 0. That is, the right hand part is 0. So in general, the homogeneous system of equations is represented by a into x is equal to 0. That is, we have converted the given system of equations into a matrix form as shown here. Okay. Here A is a matrix obtained from the given system of equations, which is known as coefficient matrix. Okay. Here you can see A as A11 coefficients of the variables x1 to xn in the matrix form. Okay. So A is given by A11, A12, A1n as the first row, A21, A22, so on A2n is the second row, and the last row is AM1, AM2, so on AMN. Okay. And variable matrix is x1 to xn, and the last one is zero matrix. Okay. So the whole system is represented in the matrix form as ax is equal to 0, where a is a coefficient matrix, x is a variable matrix, and 0 is zero matrix. Now come to non-homogeneous system of equations. So as the same way the homogeneous is represented, the non-homogeneous system of equations is also represented, but here the constants exist. That is, the first equation in non-homogeneous system of equation is a11x1 plus a12x2 plus so on a1n xn is equal to b1, where b1 is some constant, some real number. Okay. The next equation is a21x1 plus a22x2 plus so on a2n xn is equal to b2, and so on. The last equation is am1x1 plus am2x2 plus so on amn xn is equal to b. Here also the number of variables are n and the number of equations are m, and the constants are b1, b2, so on bn. The whole system can be represented in a matrix form as ax is equal to b. Okay, where here a is the coefficient matrix, that is coefficients of the variables x1 to xn. Okay, and x is the variable matrix and b here is the constant matrix. Okay. Now go to the next paper, that is, okay. So this is non-homogeneous system of equations. Okay. I've given you some example here, how we can represent a non-homogeneous and a homogeneous system of equation. The homogeneous system of equations in a matrix form is represented by Ax is equal to 0, and non-homogeneous is Ax is equal to B, where B is a constant matrix. Okay. Now come to consistency of system of linear equations. What is consistency of system of linear equation? If the given system of linear equation has a solution, then that system of equations is said to be consistent. If the given system of equations doesn't possess any solution, then that system of equations is said to be inconsistent. So system is said to be, the given system of equations is said to be consistent if it has a solution. It is said to be inconsistent if it has no solution. Okay. As you all know, homogeneous system of equations, that is Ax is equal to 0, has always a solution. It has a trivial solution, that is 0 solution. Okay. If you substitute x is equal to 0, then you get a solution for a homogeneous system of equations. So homogeneous system of equation has a trivial solution, that is a 0 solution. Okay. Now come to the non-homogeneous system of equations. So this is the non-homogeneous system of equations with n unknowns x1 to xn. Okay. To determine whether the equations are consistent or not, we have to consider the equations. We have to consider the rank of the matrices. Okay. The rank of the two matrices. Here the first matrix is the coefficient matrix and the second matrix is augmented matrix. The coefficient matrix is obtained from the system of non-homogeneous equations. Okay. And the augmented matrix is nothing but the coefficient matrix A, which includes the constant matrix. Okay. Which includes the constant matrix as a column at the end. So augmented matrix is denoted by A is to B, and the coefficient matrix is represented with A. So in order to conclude whether the system is consistent or not, we have to consider these two matrices. We have to find out the ranks of these two matrices. Okay. So now let's go to the next page. Okay. So now look at the procedure to test the consistency of system of equations in an unknowns. Okay. So this is the procedure to tell that the given system is consistent or not. First, we have to find the ranks of the coefficient matrix A and the augmented matrix A by B. Okay. By reducing to the triangular form, to the upper triangular form, by using elementary row operations. Okay. Let the rank of the coefficient matrix be R and that of the augmented matrix be R dash. Okay. The uh, system of linear equations has a solution if and only if the rank of the augmented matrix is equal to the rank of the coefficient matrix. Okay. If they are not equal, then the system of equations are said to be inconsistent. Okay. Okay. Now let us talk about the consistency of system of linear equations. If R is equal to R dash, so here R is the rank of the coefficient matrix and R dash is the rank of the augmented matrix. Okay. So if they both are equal and is equal to n, where n is the number of variables, okay, is equal to n, then the system of linear equations is said to be consistent and it has a unique solution. And if R is equal to R dash, that is the rank of a matrix is equal to the rank of the augmented matrix and it is less than n, the equations are said to be consistent and they have infinite number of solutions. Okay. Now let us conclude this with other examples. Okay. This is the system of equations, okay, which is consistent and inconsistent. So in my next video I will discuss with examples. Okay. Thank you.